Hello all, welcome to the next session of types of virtualization. So in our previous session we discussed about cloud, virtualization and containerization. So here we'll be discussing in detail about the types of virtualization. So when the virtualization is done on the application layer, we call it as application virtualization. When it is done on the server layer, it is called as server virtualization. When it is done on desktop layer, we call it as desktop virtualization. When it is done on storage level, we call it as storage virtualization. When it is done on network level, we call it as network virtualization. If the data itself is virtualized to the end users, we call it as data virtualization. Let's take a deep view of this in detail. So we all know cloud computing is again group of computers. So n number of computers are connected. We have data centers running in the background. So everything is connected together, right? And there are end users who are trying to access the data centers from their respective locality or location. So these are physical servers. What are these data centers going to have? They are going to be having literal physical servers, but unfortunately, we cannot allocate each dedicated server to a single end user, right? If that's the case, imagine the situation because we have millions and millions of users around the globe, and each user has to be allocated a dedicated server in the data center. That's not possible. So what do? The service providers. So within the data center, they have their physical machines which are arranged in racks. All these physical machines are virtualized. The server a user is trying to request is virtualized so that the servers are taken to their maximum usage capacity. So the users don't have to worry about managing those servers because it's again an intrinsic process. It's again complex inside the server in the data center. So providing scalability, utilization, resource sharing, all those are the features or the capability of a cloud service provider. So the user has not have to worry about it. So each server is virtualized so that we have a virtual server with its unique operating system plus their applications running on it to serve the user. Each of these operating systems are independent of each other. The applications are totally independent of all the virtual servers on any physical machine. You can see here in the picture, this is a traditional server architecture which has got its own hardware features or components upon which we have a single operating system and a single application running. This is highly impossible when you are having millions and millions of users and millions of requests to be processed or to be served. It's highly impossible. So we go for virtualized server architecture. When you have a hardware which could be virtualized, it is again done with your hypervisor. There are various types of hypervisors, and there are some examples of hypervisors which comes under type 1 and type 2, which we had seen in the previous sessions, like VMware, Citrix Zen Server, EX Server, and VirtualBox, Oracle VirtualBox, Oracle Solaris. So there are n number of hypervisors available in the market which will be used, which is specifically designed for server virtualization. So upon which your OS runs. So you have the virtualization here layer here, upon which we can run as many number of operating systems, and on that you can have as many number of applications running. So basically, your data center has servers, and these servers are again virtualized into n number of virtual servers. So that's about server virtualization. So this is a pictorial representation in detail. You have the physical server, which we just discussed, and we have the hypervisor installed on the physical server. And it's gonna give us the respective VMs or the virtual servers, which is gonna be working on their own isolated environment with the given OS and the applications. So next important virtualization which we will be dealing throughout the course is network virtualization. It plays an important role where we would be talking about virtual private networks, public IP, private IPs, all in detail, not limited to, and subnets. So see, we have our laptops, we are working with our laptops, we are getting connected to the applications in internet, we are Googling a few things, we are accessing our email, everything is happening because of the network connectivity, right? So as a user, as an end user, I use my device, it might be a desktop or a laptop or a mobile device. Whatever the device I might be using, I get connected to the cloud through something called internet. So without internet, it's not possible. So what is this internet? It's again collection of physical network devices, which enables the connectivity between the end user and the cloud service provider, right? So we are sitting in front of a laptop, accessing the cloud service providers through the internet cable with the services provided by Airtel, Act FiberNet, and all these providers, right, who provide the internet service. Everything is ultimately connected through the wired network medium. When this is done on cloud with the help of virtualization, we call it as network virtualization. How does this happen? Say, this is a network. So here we have a user A1 who's trying to access the cloud service provider, CSP, through his network. Let's dissect this network. I have a given network which I use to access the internet. So when I divide this network further, or when I partition the network further to send my packets from user 1, user 2, user 3. When I use a dedicated network, I virtualize the network so that 3 users can use the network to access the resources on the cloud. I call it as network virtualization. There are some primary factors which define a network's capability. One important of those is bandwidth. And we have another important factor which is capacity. And we have another important factor which is latency. We have like throughput, input, output. So these are the factors which decides how well a network is organized or how well a network is efficient enough to serve the user. So your network is divided into logical divisions, not physically, but logically it will be divided into different channels where each channel could be assigned to the specific user. So what's the advantage of virtualizing the network? Obviously, it provides faster speed, security and flexibility, where millions and millions of users can access the same network in logical way to access the physical data. So everything that you're gonna be accessing or working on will all be virtual resources. Say you have a public network or public user A in a public network, a user B in a private network. So these users are supposed to get connected to the virtual network through something called subnet, and you can establish your connections and you can work on your workloads accordingly. So that's about network virtualization. So we have a few more concepts like content delivery networks, CND, software defined networks. So these two networks plays an important role when it comes to network virtualization. So as we proceed further, when we work with any cloud service providers in our upcoming sessions, we would be seeing about, or we'll be working practically on how content delivery network works and how software defined network works. And we have something called network function virtualization. So see, all these services are again microservices. To the end users, microservices serves as the basic medium for virtualization. And that's the important factor which makes every user to access the cloud, which is a common medium, without any interference from one user to the other user. So the next important virtualization type that we're going to be seeing is storage virtualization. So on the storage level, when you virtualize the storage databases or the storage mediums, which is going to be having the user data, you call it a storage virtualization. But what enables the storage virtualization? Your network virtualization. So all your network resources will be grouped together and it appears as a single medium of device serving the user. So let's say example of Google, right? So as an end user, I'm trying to give www.google.com from my Microsoft Edge browser. So when I am getting served by the page as www.google.com, so Google's page gets displayed to me. I can give the keywords, I can go on with the search, I can do whatever I want. The same happens for every user. So when I sit in front of the laptop, it gives me a view as though it is getting delivered from a single storage device, but it doesn't actually happen. They are actually virtualizing the storage devices so that the users are appropriately served. So that's done by a central console, and that's the problem of your service providers like Amazon service providers, Microsoft Azure, Google, Netflix for streaming movies, Amazon for streaming movies, right? That's how it happens. So they have a common storage medium which is virtualized so that n number of users can access it at a given point of time. So what happens ultimately? It gives you high performance storage network. So your storage area networks are commonly used for this purpose, your storage virtualization, which could give you high performance efficiency, running parallel workloads concurrently with higher availability and higher throughput and low latency. So that's how it happens. So we have a physical storage, which is the backbone of working with any virtualization, upon which we have the virtual layer, and we would be given a dedicated virtual volume, which is the space which would be in gigabytes. It starts from gigabytes basically. As of our local machine, it starts from megabytes, right? KB, MB, GB. And here in cloud terminology, it starts from gigabytes to terabytes to hexabytes to petabytes. And it is all done from a common server, right? So a literal space would be given for the user in the server to use the data, to view the data. That's storage virtualization. What is application virtualization? See, this happens on the application layer. So this application layer itself is virtualized, which is separating your hardware and the operating system. So the applications can run anywhere, anytime, without being dependent on your hardware and your operating system. So I would like to give a real-time example. See, there are some OS specific applications available in the market. Not all will be able to download all the applications. If I'm running Windows 8 in my machine, I have only specific drivers, specific packages of software which I have to download so that it is going to be compatible with my operating system to get executed and get my task done. What do you call such type of application has? Such type of applications are totally dependent on your operating system, on your physical hardware, which are homogeneous applications. But there are some applications in the market which will run irrespective of your physical hardware configuration or your operating system. So those are heterogeneous applications. So you don't have to worry about the compatibility, still the application will work. So when virtualization is done on application, your hardware and the operating system is literally taken out from the application layer, and your application itself serves as a microservice. So now your application can run on any machine irrespective of its features and configuration. So we have a physical machine, and there's obviously going to be an operating system on that, and it's going to have its own configuration. Let's take an example, a simple example of C and Java. C is a programming language which is totally tied to the operating system and the execution environment, which means if I'm writing a code in C and if I'm generating the exe file, which is the executable file, it is write once and read once and write once, which means I can just execute it in the environment which I just created. I cannot cross-platform this application. But when it comes to Java, so it is totally object-oriented. It's also object-oriented, but it has something called class, which enables Java to be write once, run anywhere. Write once, run anywhere. Which means I am working on my operating system Windows. I've downloaded the Java development kit. I am programming in Java. I can run it in any operating system. Say I would want to share my code with my colleague and he or she is having Linux. I can share it to the colleague of mine. It is not going to be changing any features or the code inside whatever I have typed or I've developed. So you call such type of environment as heterogeneous environment. Applications which are suitable or compatible for such environments are heterogeneous, and applications which are tied up to the existing environment are homogeneous. So in cloud, virtualization is enabled to the applications where the users can run any application on Windows, on Linux, and vice versa without being dependent on the hardware features of your system. So that's what is shown here. So there is a Word file, Excel, and other files which say any application. so which is again virtualized in a stored environment, and it is streamed across various users. So one perfect example which I would like to quote here is your Google Drive and your Google, right, Gmail account. So when you log into your Gmail account, at a given point of time, there could be n number of users who are simultaneously working on Google Docs, Google Drive, Excel, right? Changes done by one user is reflected to the other user, and vice versa. So it is collaboratively enabling you the application in a virtualized manner, where you can work on projects, you can upload your data, you can work on analytics data in a collaborated manner. Okay, so desktop virtualization is again a fine example of emulating your desktop environment itself. So how is it done basically? So this we would be seeing throughout the laboratory session when you're working with AWS or Azure. So we would be creating a user account. We would be logging into the console. We would be in launching the instance, and a desktop would be displayed to us, just like how you have your laptop. So there are servers which are virtualized to give us the virtual desktop upon which you can work on your applications, you can work on your workload. So this serves as a workstation basically. And what is data virtualization? See, as we all know, there are huge amount of data that's being generated on daily basis. Every year the data is exponentially increasing, and it's all being stored on the servers as dump data, right? The users are generating data, the servers are generating data, the network is generating data. Every single user is generating data exponentially. And this leads to something called big data analytics, and data scientists, AI, machine learning, training the data, supervised learning, unsupervised learning. So to make clarity, to make it easily accessible for the end users, the data itself is virtualized. Say you would want to access stock market data. There are specific dedicated servers or a single point through which you can access those data. Say you would want to work on big data analytics like DB, a specific DB data like Cassandra, Oracle. So to perform online transactional processing like extraction, transformation, and loading. You have specific servers or a single point which hosts such type of data. So there are various resources which generates data, like database warehouses, enterprise applications, SaaS applications specifically, your XML, which are the structured data, Excel files, your big data, NoSQL, and collaborating Web 2.0, which is semantic web services. And we have PDF, documents, index emails, video data, audio data, not limited to, right? So these resources are going to be virtualizing the environment and provisioning the users appropriately based on the request from the consumers or the clients. So in order to achieve that, the data is virtualized and stored on the servers, and based on the domain the user is requesting, a single point would be available to make the user access the data. So this has both structured, unstructured, and semi-structured types of data. So that's about the types of virtualization. And in next session, we will be discussing about types of cloud models like public cloud, private cloud, when we have to choose public cloud models, on which situation we have to go for private cloud models, combination of these models, which you call a hybrid model. So all these in detail we will be discussing. And from there on, we will slowly enter into Amazon Web Services and Microsoft Web Services. we would be dealing about creating instances. We'll be having practical sessions in creating instances. And yeah, so with that, I am finishing the class today. See you all in next session. Have a good day. Bye bye.